Okay, today I'll discuss about some numerical examples and uh, that is regarding the lateral arc pressure. First, example. This example is related to the active arc pressure. Okay. For a reminder, I may show the equations for the active arc pressures. The equations for active arc pressure is like this. This is the equation, general equation for active arc pressure. This is the equation for cohesionless soil where the value of C is equal to 0, and this is the equation for active arc pressure for cohesive soil. This is for cohesionless soil, this is for cohesive soil. Now you may write down the equations in your copy. Now we'll going for going for some numerical example directly. Okay. First of all, you should read the question carefully. That is, a vertical wall of 6 meter height has sand behind it. That means the backfill soil is sand. That means some cohesionless soil is there as a backfill at the behind of the retaining wall. The surface of the sand is horizontal. That means the top surface of the backfill is horizontal. There is no slope. If there is slope, there may be some other cases that will be discussed later, but the general condition, which is the horizontal backfill surface, here we are using that. Now there is no water table at the site. Obviously there may be some condition for water table and we'll discuss later, but the general condition is there is no water table, there is no water content at the backfill soil, and we are using that general condition for this example. Now determine the distribution of active arc pressure. Distribution of active arc pressure means obviously you have to calculate the values of active arc pressure at the top and at the bottom of the retaining wall, at the bottom and top of the retaining wall, and you have to draw the pressure diagram that I have discussed in the previous class. I have given a simple idea about that arc pressure distribution diagram in the previous class, and total lateral force. This may be the new thing to you, and we'll discuss about this later. Total lateral force on the wall per meter length. About this total lateral force we will discuss today, and the characteristics of the sand, characteristics of the backfill soil, that is sand here. The characteristics of the sand is C is equals to 0, phi is equals to 30 degree, and gamma, which is the unit weight of the backfill soil, is equals to 18 kilonewton per meter cube. These are actually most important data for these types of problem. Now, starting before starting the solution of this problem, here you may see the diagram of the problem, or diagramical representation of the problem. That is, there is a retaining wall. This is the backfill soil. The surface of the backfill soil is horizontal. There is no slope. There is no water content in the backfill soil. The height of the wall is 6 meter. Uh, so directly the height of the backfill soil is also 6 meter, and the characteristics of the backfill soil is unit cohesion is 0, phi is equal to 30 degree, and unit weight is kilonewton per meter cube. You may write down these values, these data here in the place of backfill soil. You may write down these data which is given in the problem. You may write down. Okay. Now coming to the solution. Now, first of all, you may write down the equation for the active earth pressure, because the first you have to determine the active earth pressure. This one you have to determine. That's why you may write down the equation for active earth pressure. You may write down in your copy active earth pressure, which is this is the equation for active earth pressure. Now we have to calculate this thing Ka. There is the value of gamma is given and value of H is given. So first of all, coming to the value of Ka, which is coefficient of active earth pressure. you may calculate this value is equals to, yes, yes, okay, this one, right? Okay, now then the value of gamma is 18 and the value of h is 6 and the unit of this is kilonewton per meter square. And you may calculate the value that is equals to 36 kilonewton per meter square. Okay, now coming to the diagram, pressure distribution diagram, because here determine the distribution of the active earth pressure. Now when the height here at the top of the retaining wall, the value of h is equals to 0, and when h is equals to 0, then total value of PA or active earth pressure is equals to 0, and this is one equation of straight line, and the value is directly increasing from 0 to value of 36, from 0 to 36. Then if I want to draw the earth pressure diagram, then it will be like this. At the top this is 0, and at bottom this is 36. The value at this point is 36 kilonewton per meter square. Now this is actually 36 kilonewton per meter square. This is the pressure diagram or pressure distribution diagram for active earth pressure. Now coming to the next part, that is the total lateral force on the wall. Total lateral force means here the pressure is 0. Here at this point, at the bottom point of the wall, the pressure is 36. That means this pressure is distributed from 0 to 36 throughout the height of the wall. That means the force is actually the area of this diagram. The area of this diagram is the force. Pressure multiplied this. This pressure means kilonewton per meter square. This meter square, if you multiply meter square, which is an unit of area, you may get this force. Okay. Now the area of this pressure diagram is actually the force acting on the wall. That means total force, or this total force is termed as active thrust, active thrust in case of active condition. Total force on the wall, you may remember this thing, this active thrust, or the term thrust. Thrust is actually total force. This total force is equals to, this is the diagram is of triangular shape, so the area is nothing but half multiplied by 36 multiplied by height. This much of kilonewton, but here this 36 is kilonewton per meter square, and we have just multiplied 6, which is the value of height, not area. That's why this kilonewton, this much of kilonewton is per meter width of the retaining wall. Here, this the wall per meter length of the wall is written now. This length is actually the dimension of the retaining wall perpendicular to the surface, to this screen surface, perpendicular to the screen surface. That means this is the height. One dimension is height, one dimension is breadth, and another dimension is width, that is length of the retaining wall, which that dimension cannot be shown here. Actually this is the perpendicular direction of the screen. That per meter of that length is this much, and the value is the value is 108. I think you may check the calculation. 108 kilonewton. This is the unit of force per meter length of the wall. This is the value of total force, which is equals to the area of this pressure diagram. Area of this pressure diagram. Okay. And another thing, for this case, this is simple, that is the point of acting of this force. Point of action of this force equals to the CG of this area. CG of this area. Now the shape is triangle. That means the CG is at 1/3 distance from this point and 2/3 distance of the top point. 1/3 distance from this point and 2/3 distance of this point. That means you may write down two by 3 multiplied by 6 meter equals to 4 meter from the top of the wall. This is actually I may point out the point of action. Sorry, this will be acting in this direction. Okay, this this distance is 4 meter and this distance is 2 meter, and from top of the wall 4 meter below, and from the bottom of the wall 2 meter above, the this total force or total active thrust is acting 4 meter below. This should be written 4 meter below from the top of the wall. Okay, this is the one simple example, but there are different difficult parts, different difficult uh, addition of conditions and data, like one example or one additional data that may be given, that if the water table, there may be water table at the site. If the water table behind the wall is at 2 meter below the surface of the backfill soil, then same thing, same parameters you have to determine. For the previous example, the other data are same, but only there is one additional data, which is the condition of water content. Water table is at the 2 meter below the surface of the backfill soil, and if the water table is there, that means the characteristics of the soil, uh, that portion of the soil which is submerged into the water table, submerged into the water, the characteristics, mainly the gamma or the unit weight of the soil will change. The submerged unit weight of the soil will be changed. I have just given the saturated unit weight may be taken as 21 kN per meter cube. As the soil is submerged into the water, the unit weight of the soil will be changed, and the saturated unit weight is given as 21 kN per meter. Then you have to determine the active earth pressure and total lateral force or total lateral active thrust on the wall. The same conditions, other data, other conditions are same. Okay, now one thing, in your exam, semester exam, or other numerical problems, you may face one problem, that is this gamma saturated is given as only gamma. That means unit weight of the soil submerged into the water is given as 21. That may be given, or may be given as 12 or 13 or 11 kiloliter per meter cube. That also may be given. Now, if this value, gamma value of the unit weight of the soil submerged into the water is given, is greater than that is given in the general condition when the soil is not submerged into the water, the gamma is given this value. If this value is this value greater than this value, then if the normal unit weight of the soil or general unit weight of the soil is greater than the submerged value, then this value is actually submerged unit weight. But if this value submerged unit weight or the soil unit weight of the soil submerged into water is given greater than the normal unit weight or the general unit weight of the soil, then this value that is given, this value will be considered as the saturated unit weight. Now you know the relationship between the saturated unit weight and submerged unit weight is equals to saturated unit weight is equals to submerged unit weight minus unit of water. Unit of water may be considered as 10 kilonewton per meter cube, and you have to find out only the value is greater than the unit weight of the soil, this value is greater than the unit weight of the soil or lesser than the unit weight of the soil. If lesser than the unit weight of the soil, then that is submerged unit weight given, and if this value is greater than the unit weight of the soil, then that is this value is given as saturated unit weight. And if saturated unit weight is given, then you have to calculate the submerged unit weight by subtracting 10 kilonewton per meter cube, which is the unit weight of the water. Okay, now here this value is greater than, and we have to subtract the unit weight of the water from this value. Now for this case, we have to this will be same this one, because up to 2 meter below the surface of the backfill soil there is no water table, and the H, the value of H will be considered as 2 meter here, and this is uh, 1/3. Okay, I'm copying only from here. Only the height will be different, that is 2 meter, and this will be 12 kilonewton. 12 kilonewton per meter square. This is the first part of this problem, that is from top of the retaining wall to the 2 meter depth of the backfill surface. Now at 6 meter below the surface of backfill, that means now we have to calculate from 2 meter below the surface to the 6 meter below the surface. That means total height in this stage is 4 meter, from 2 meter depth to 6 meter depth. total depth is 4 meter, and here the total vertical stress or vertical pressure, what is gamma h in this case, that is calculated as okay 18 multiplied by 2 for the first layer where water table is not there, plus 4 multiplied by 21. This is for saturated unit weight of the soil, but actually unit of weight of the soil is minus the unit weight of the water, that means 10. You may write the calculation like this, or maybe like this, same thing, same, that is just I have calculated the submerged unit weight from the given saturated unit weight, that is 21 minus 10. 10 is nothing but the unit weight of the water. Okay, now this is equals to, this is multiplied, okay, not point, multiplied by 2. This is equals to 36 plus 44, I think, equals to, I think, 80 kilonewton per meter square. And this is the vertical stress. This is not the active pressure. To calculate the active pressure, you have to multiply the coefficient of active pressure, which is 1/3. This is equals to this is as 26.6687, like this, much of kilonewton per meter square. This is the active pressure distribution, and if I copy this figure pressure diagram, then this will not the diagram. This will be, there will be some modification in this diagram, that is for first layer up to 2 meter depth, the value is 12 kilonewton per meter square, and after that in the next layer where the soil is submerged into the water table, then the value is 26.67 kilonewton per meter square. That means the pressure distribution diagram will be like this. This value is 26.667 kilonewton per meter square, and this value is 12 kN per meter square. This value at the depth of 2 meter, the active arc pressure is 12 kN per meter square. At a depth of 6 meter, the value is 26.667 kN per meter square. Okay, this is the pressure diagram. And another thing, there is not only soil, but at this portion, at the second layer below the 2 meter depth, this layer, there is a layer of water. If we can remember, then uh, the vertical and horizontal pressure due to water, the vertical and horizontal pressure due to water is same, because we have studied in physics that in all the direction, in the direction of vertical, horizontal or any other angular direction, the pressure due to the water will be same. That's why there will be another part of pressure due to the water table. Sorry. And that pressure is starting from this to this. Okay, this part of the water pressure is for the water table or the pressure of water, and the pressure of water, pressure of lateral pressure due to water is similar as the vertical pressure of the water, and that is nothing but the gamma multiplied by h. Now gamma of water is 10 and h is here is 4 meter for the depth of water table. Total pressure is 4 multiplied by 10, that is 4 multiplied by 10 kilonewton per meter square, that is equals to 40 kilonewton per meter square. And Okay, this is the pressure distribution diagram when water table is there. Okay, now coming to the next part of the problem, that is total lateral force uh, and uh, active thrust equals to the area of this figure, the area of this pressure distribution diagram is equals to half of 12 multiplied by 2. The area of first triangle, the triangle at the top of the figure, this triangle, the area of this triangle, half of base multiplied by height plus plus we may divide the trapezoidal portion, this trapezoidal portion into two parts, one sorry, one rectangular part and another triangular part. The width of the rectangle is 12 meter, 12 kilonewton per meter square, and the width of the base of the triangle is this much minus 12 kilonewton per meter square, and height of both the cases is 4 meter. And first taking the triangle, half of 26.667 minus 12 multiplied by 4 plus the area of triangle is this, area of triangle is this portion of triangle, this triangle is this one, and the area of rectangle is 12 multiplied by 4 plus plus another triangle is there for the pressure of water, and this is equals to 40 multiplied by 4, and this much of kilonewton per meter length of the wall equals to, can you calculate the total value is this is most probably 169.5 or something, this much of kilonewton per meter length. This is the total active thrust or total lateral force for this case when there is extra water table condition is there, and the point of action here, there is one triangle, that's why we have calculated only CG. Okay, someone is saying something. But here four parts are there, three triangles and one rectangle. That's why we have to calculate the CG from the CG by the calculations of CG of irregular figure, that is the area of this triangle is 12. Multiplied by CG of that triangle. If we are calculating from the top of the wall, that is 2 multiplied by 2/3, that means 4 by 3. This is the this plus, coming to the rectangle part, the area is 5 multiplied by, in case of rectangle, the CG is at the midpoint of the rectangle, that means half of height, that is 4, plus another triangle, sorry, this one is not the area of rectangle, this one is the area of triangle, that means this is also, sorry, this is the area of triangle, this one is the area of triangle, and this area multiplied by CG distance from the top, that is 2/3 of 4 plus 2, 2/3 of 4 plus 2, that is the distance from the top of the CG of this triangle, distance from this point to the CG of this triangle. Now coming to the rectangle part, that is the area is 48. Yes, the area is 48, 12 multiplied by 4, and CG distance from the top of the wall is equals to 2 plus 2, that is the CG of the rectangle is at the midpoint of the figure, that is at this point, plus 2 is the depth of first layer, that is 2 plus 2 plus, for this triangle the area is, sorry, there will be 1/2. This is the area of one triangle, and this is equals to 80. The area of the last triangle is 80 multiplied by CG distance, same as this triangle, that is 2/3 of 4 plus 2 divided by total area, that is 169.5. Total area is this one. This is the CG distance of this figure from the top, and this is equals to, you may calculate the value equals to 4.24 meter from top, or from bottom you may calculate also, that is 1.76 meter from bottom of the wall. Okay, this is the total solution of this problem with and without water table in the site.